hopefully it got everything, but I'll let it run a few seconds in case it's shut off. All right, so let's say if we have for absolute value of r is less than 1, the sum from n equals 0 to infinity of n times n minus 1 times r to the nth power equals 2r squared plus 6r to the third plus 12r to the fourth, and it keeps on going and going and going till eventually it equals 2r squared over 1 minus r to the third. Okay, use this to find the power series for f of x equals 2x squared over 1 plus x to the third. Okay. So this one, once again, you're just going to match it up there. Okay. It's just a little thing that would probably catch you off guard. You would think, oh, okay, just make r equals x, and we almost. Yep, it has to be negative. So 1 plus x, the third would have to be 1 minus negative x to the third. Thing is, if your r is equal to negative x here, then your r would have to be equal to negative x up there also. Okay. So your f of x, which is 2x squared over 1 plus x to the third, would have to equal 2 times negative x squared over 1 minus negative x to the third. That's one of those really easy mistakes. So clean that up a little bit. Okay, again, we let r equals negative x.
Yeah, I guess it's squared. It doesn't matter if we just make the top one negative.
Oh, no, it doesn't matter at all.
Okay.
Yeah. Actually, that's a good point. Let me.
That's why you can just kind of throw a negative in there.
Yeah.
And not really matter.
Yep, it's the same thing. So x squared is actually equal to negative x squared.
So what do you do if it's not a even exponent at the top?
Well, if it's not even, I'm trying to think the best way to approach that one.
Just skip
Because I know most of these should all work out that way,
Okay,
but I'm
okay.
trying to think if it
That's
didn't work
okay,
out.
That's okay, that's all I need. That's all I need.
Yeah, they should. They all. Yeah, they
This
all
is
work
as hard
out.
as I had to work for the question, it's all I need to know.
Yep, that's it. All right, so we know that the sum from n equals 0 to infinity of n times n minus 1 times r to the nth power, since we made that r equal negative x, becomes sum from n equals 0 to infinity of n times n minus 1 times negative x to the nth power. Okay. And remember that negative x can be negative 1 times x. So from n equals 0 to infinity of n times n minus 1 times negative 1 times x to the nth. You don't really have to do that step, but kind of a quick explanation. Negative n equals 0 to infinity n times n minus 1, and that becomes negative 1 to the nth power times x to the nth power. Or you can move the negative 1 to the nth in the front. Either one would work. Yes.
Do you have to separate the -1 from the x? Or could you just leave it as like negative x to that?
You could leave it, but I think in Newton they would want it to be separated because if you plug it in, negative and negative would be positive anyway, so it would still work out. But I think in Newton they wanted it as a -1
Okay.
to the end.
You knew it's really particular.
Yeah.
I've gotten answers wrong. Like, I've gotten answers completely correct and Newton told me they were wrong.
Yeah, it doesn't-
Yeah.
Which is really, really annoying.
Actually, that's why my voice is a little bit hoarse because I was just in there with one of the representatives for like the past 2.5 hours
Wow.
telling them a whole laundry list. That's why I wanted the survey. So I'm in there,
Okay.
okay, this is wrong, that is wrong, that is wrong, that's wrong, that's right, that's wrong, that's wrong.
I did one that was like creating
Mhm.
the equation for a sequence or something like that.
Mhm.
And I got one, but my equation worked for all the values it gave,
Mhm.
but there was multiple different equations that it could have been.
Yeah, that's what I
So I
told them.
put mine in there, and I was like, and it told me it was wrong at first. I'm like, okay, rechecked it real quick. I'm like, no, this works. So I just hit resubmit again to see what their answer was.
Just a different version of the
It was
same
a
answer.
different version of
Yeah,
the same answer.
that was actually one of the things I brought
I'm
up.
like, that's annoying.
How did the survey go?
Not bad. They're actually going to come back again tomorrow. So he's going to bring the guy that's in charge of the tech department. So he's going to come back, and then we have a meeting on Friday, and they're all going to come back again Friday. So
So is this like a trial thing we're doing?
this is the first semester we've used Newton. So
Okay, and are you the only teacher that's using it?
oh no,
Everybody.
everybody,
Yeah,
yep,
using it?
yep, the whole math department. So
Okay.
they're kind of debating. I think math and chemistry I think chemistry might be using. I'm not sure.
Okay.
But they're trying to get it to where if they can work out all the bugs.
Well, because
Then-
Base
have-
chemistry isn't using it.
Oh, it's not?
No.
Oh, okay.
I'm taking like Chem 1010 and
Mhm.
they're not using it.
Oh,
so-
okay.
Can you bring up that last page for a second?
Oh, sure. With that, I thought everyone was finished. There you
But
go.
granted, we really don't have much homework. It's like
No.
a reading that we do and that's it.
Oh, yeah.
Here's
I
the
know-
worksheet, fill it out from the reading. Other than that, we have our in-class, like, little worksheets we do
Mhm.
and the chemistry labs itself.
No, so
So
it
we
doesn't
don't
go
really
like
have any use
deep
for
into it
in
yet.
there. Yeah, there's nothing we can do unless they want to just add different kinds of homework into the program.
And the
Or
one
into
good thing
the
about it
curriculum.
is, which I'm hoping they do get all the bugs worked out,
Mhm.
because if you buy let's say if they use it for every class, if you buy the $80 for 2 years, that's every class you have just for $80 for the whole 2
Okay.
years. So that's why we're trying to really work with them to get it all worked out. So
Right.
if you come here, you have $80 worth of books to buy, and that's it for 2 years. So hopefully, if we can get all the little kinks worked out, it's a whole lot.
That'd be really nice.
Yeah, especially considering my calc book was $280.
Oh, jeez.
That's right. I'm like, man, y'all getting off easy.
Right.
Like, man, $40 for
For
2
Calc
years.
1?
But actually, it was a Calc 1 and 2
Oh, same-
combination book.
Oh, okay,
Same.
that's how it was. for
Yep, so-
both of us to do.
Wait, the teachers have to buy the calc books too?
Oh no, teachers get them for free.
Okay, that's what I was.
Oh no, I'm talking about back when I was a student.
Okay,
Oh, yeah.
okay. That's
Oh,
why
no.
I was like, wait, you have to buy the book for your
No.
own class? That's
Oh,
a
no.
little interesting.
Nope, they actually give us the book. So.
That's rude.
Still,
Right.
I know what it's like to have to buy
Right.
books. So
All right, you're hired. Give us $400.
I know. Yeah, y'all would be getting taught out of what was that Khan Academy? Okay, look at this here. So okay, rewind it a little bit. And,
Now,
yeah. No, so
What is it called, Symbol Lab?
exactly. So. All right, so let's say we go to the properties of power series. Now we're going to look at the sum and difference. Of two power series. Okay, so let's say if we have a power series, sum from n equals 0 to infinity, some c sub n, x to the n power, and it converges to some f of x. So the series converges to f of x. Same way it did before, where you got through all of that stuff and ended up with some function of x. And let's say I have the sum from n equals 0 to infinity, some d sub n times x sub n. And it converges to some g of x function. Okay. So if you add those two together, and of course you just converges to the sum of f of x and g of x. So then the sum from n equals 0 to infinity, c sub n x to the n power, either adding or subtracting, d sub n x to the nth power equals f of x, either plus or minus g of x. Okay. So in other words, the sum or the difference of the series converges to f of x plus or minus g of x. Clean that up just a little bit. Converges to f of x plus or minus g of x. Okay. And the odd thing about it is a lot of these problems, in my opinion, had nothing to do with this formula, but it was one of those things where it was like, okay, well, they wanted you to teach the formula, so this is the formula, and you'll see what I'm talking about. It's like, okay, I didn't even need to know the formula to do that, but okay. Oh, anyone's still writing. All right. Oh, wrong one. Okay, so let's say, for example, if we let the sum from n equals 0 to infinity of 3x to the 2n plus 1 power over 2n plus 1 have an interval of convergence of negative 1/3 to 1/3. And the sum from n equals 0 to infinity, say x over pi to the nth power, have an interval of convergence of negative pi to pi. Okay, so find the interval of convergence of the sum from n equals 0 to infinity of 3x to the 2n plus 1 power over 2n plus 1 plus x over pi to the nth power. Clean that up a little bit. Oop. And give the answer using interval notation. Okay. So, like I said, the odd thing about it is you can solve it without even knowing the formula. So if you notice that you go from negative pi to pi, remember that's the interval of convergence for the sum of x over pi to the nth power. And from, I'll mark that as 0, and from negative 1/3 to 1/3, say negative 1/3 to 1/3, because remember pi is just 3.14. Clean that up some. And this is negative 3.14. And that's 0.33 and negative 0.33 and negative 0.33. Okay. And this is your interval of convergence for 3x. Let me make that a little bit higher. Could have made that lower. Separate that some. The sum from n equals 0 to infinity of 3x times 2n, well, to the 2n plus 1 power over 2n plus 1. Okay, so really, they both have a common interval between negative 1 and negative 1/3 and 1/3. That's your interval of convergence. That's what I'm like.
Write it in interval notation.
Yep. That's it. So really, once you figure out what the common interval is, that's your interval of convergence. I'm like, they could have picked some better problems because this, but no, well. Okay, so they both have a common interval of convergence of negative 1/3, 1/3. And that's your answer.
Now what is it if it's outside of it? You just whatever overlaps. It's just that simple.
Nope, it would have to be whatever
Whatever's on
interval converges for
Intervals
both of them.
included in both.
Yep,
Right,
included
yeah,
in both.
overlap.
Yep. So if it did overlap, let's say. So let's say for this one, if you had the interval for the first one was between negative 1/3 and 1/3, and the interval for the second one was between 0 and negative 5. Then it would be negative 1/3 to 0 for both of them. Let me kind of, so no one sees that and thinks that's part of the answer.
Right.
All right. Does that make sense? All right. Oh, anyone's still writing?
So how does that relate to the formula at all?
It doesn't. That's why I was like,
All right.
I just think they just picked bad problems. I'm like, because I've seen problems use the formula that relates better to the formula, but these particular problems didn't really relate to the formula. So I just teach the type of problems you're going to see. So
What if the intervals are completely separate, there's no overlap?
then the interval of convergence would just be 0. Oh, that empty set.
Like between the two?
Nope. So if you have, if I'm understanding it correctly, so let's say if one is between negative 5 and 5, and the other is between 8 and 15.
Yep.
Yep. Then the interval of convergence would just be an empty set
Okay.
because they don't converge for both of them.
Okay.
Oh, make sure no one mistakes that as part of the problem again. All right. Okay, so let's say, for example, if we let, actually I want to get a decent one here, the sum from n equals 0 to infinity of a sub n x to the nth power converge on the interval negative 1/4 to 1/4, and the sum from n equals 0 to infinity of b sub n x to the nth power converge on negative 1 over pi to 1 over pi. And again, we find the interval of convergence for the sum. From n equals 0 to infinity a sub n x to the nth power plus b sub n x to the nth power. Okay, so just like before, you write out your number line, you get your 1 over pi and negative 1 over pi, which is about 0.31831, and negative 0.3831. 1/8. A lot of 1s and 3s in there. 31831. And 1/4 is 0.25. And negative 1/4 is negative 0.25. So no, that's your common interval of convergence. So that would be the interval of convergence.
What is it about this was so hard?
Nope. I'll just put IOC. Negative 1/4, 1/4. I mean, these do kind of lead into the next section, but I still think they could have gotten some better questions. At least more relevant questions. All right. So any questions on this? Yes.
Okay, so the past few have been where you're adding the two sets. What if they're subtracting?
Oh, if you're subtracting, you're still just looking for the common interval of convergence.
Okay.
Yeah.
I was just saying, I'm like, well, we've done the sums. What are the
Yeah.
differences?
Same thing. Just a common interval of convergence.
Just common,
Yeah.
okay.
I know when something looks too easy, it's like, okay,
Right,
it
I
has
was
to
like,
be.
what's it gonna be?
When's the
intervals
shoe
where
gonna
only
drop?
intervals where they don't
Yeah.
overlap? Or?
Yep, no, at least not yet. No shoes dropping. So.
Okay.
And the product and the interval of convergence is a little bit different, but still about the same. So if we have the product and the interval of convergence. Okay. So again, let's say if we let the sum from n equals 0 to infinity, c sub n x to the nth power, converge to f of x, and the sum from n equals 0 to infinity of d sub n times x to the nth power converge to g of x on a common interval. Okay, so they kind of introduce you to the idea of a common interval. Uh-oh. Okay, so first, let's say if you have some m greater than or equal to 0 and some value of b that is any real number. And you have the power series.
If n is greater than or equal to 0?
Nope, m. And the reason is, I'll show you in a second why m was
I'm like,
picked.
where's n?
So the sum from n equals 0 to infinity of b times x to the nth power times c times x to the nth power. And the only reason you picked m is because it's m and n aren't, if you pick n, that means that these two will always be the same. So by picking m, it's possible it could equal n, but it could be a different number also. Okay, so that product converges to b times x to the n power times f of x on the common interval. Okay, and number 2, again, if m is greater than or equal to 0, and the number b is any real number, then the sum from n equals 0 to infinity of c sub n times b,
Can you move it up a little?
oh, sure, b times x to the power of m, and have that times the nth power, that converges to f of bx to the n power for every value where b times x to the power of m is an element of your interval. So that kind of curved E, it just means an element of.
So that's bx to the m,
Yep, b times x to the power of m.
and then that's the power n.
Yep, is an element of your interval I. All right, so for example, let's say if we let the sum from n equals 0 to infinity of n minus 1 times n times x over 5 to the nth power have an interval of convergence of -5 to 5. And we have the sum from n equals 0 to infinity. Oh, actually, you don't have that one on this one. Thinking of the next problem. Okay, so let's say we want to find the interval of convergence of the sum from n equals 0 to infinity of n minus 1 times n times 9x over 5 to the nth power. Okay. So we know that, well, basically you might as well say it was given that the sum from n equals 0 to infinity of n minus 1 times n times x over 5 to the nth power has an interval of convergence of -5 to 5. Okay. So really all this means is that x is an element of -5 to 5. Or you can just say x is between -5 and 5. Okay. So that means if you have the sum from n equals 0 to infinity of n minus 1 times n times 9x over 5, we know that will converge